everyone. My name is Pradwin. I am an artificial intelligence and data science student studying third year in Nifty Meenakshi Institute of Technology. So I'll be explaining my project. So my project is Art Style Recognizer. So what is Art Style Recognizer? So it's a core machine learning model where it predicts the brushstrokes, color palettes, and geometry of the art or painting that you upload. So let's imagine that you are going through some streets and you find some paintings there. So there won't be any description. So that time this model will be helpful. So we have a live demo here. So this is the application I was talking about. So we have the user interface here, UI UX. So when you click here, we get an empty palette. So have some test images here. We shall upload some of the images. So you can see the model is analyzing the artwork, all the process. And finally, we get the output. It depicts the style, title, artist, time period, and a small description about the art. So we'll upload some more test images. For example, you can see the artwork process successfully. And when you scroll down, you get to see the details about the painting, title, Shakuntala, artist, Raja, Ravi Verma, and description. And also you get to ask chat box where you can ask questions on the painting. Let's say, what is the So we ask questions about model and it gives us the answer. So it gives us in a very short form, which is needed to know about the art. Then in the left panel, we have the recent images that we have searched about it. Then finally comes the information about the system and GitHub link. So yeah, that's about the model. So coming to dataset. So the dataset I used is from Kaggle, and the size of the dataset is 29 GB, about 42,500 high resolution images. And coming to classes, there are 13 historical classes. You can see all those 13 classes here with the amount of images in the dataset. Coming to accuracy and matrix. So accuracy, after training of 10 epochs, we got 97 of training accuracy and 77.6 score of validation accuracy. And we had to do data rebalancing between few classes where some of the classes had larger data set and some had few data sets. So then confusion matrix, I'll be showing confusion matrix in later. So next comes architecture. So architecture, we use CNN, pre-trained model ResNet 50. So which has about 50 layers to predict the art style, and it is very useful in pointing the brush strokes and color palettes. Next comes the LLM. So I used Gemini 3.6 Flash for further details about the images, and we integrated both CNN and the LLM together for the UI UX. Showing more about the codes. So these are the Python scripts. I did complete project on VS Code. So this is a dataset where you create path and domain for the project. Then about dataset, we resize the dataset. This is image size 224 and batch size is 32. Then coming down. So yeah. Next is model. So this script is used for implementing the ResNet 15. And here we unlock first, in the beginning, I used only first and second layer, but the accuracy was just 65%. Then I had to unfreeze layer 3 and layer 4, which jumped the accuracy from 65 to 78. Then this is the training script where we used about 10 epochs to train the complete dataset. So I used around 34,000 of high resolution images to train the data. Then this comes the predict. So here I used the remaining 8,500 images to test and validate the model. And in the end, one image to test whether it's this part to test whether the model is accurate or not. Then we come to the LLM part, where I used Gemini API key and Gemini 3.6 Flash. Is evaluate script where we get to have confusion matrix, and this will be our model's confusion matrix. So you can see the errors are still in single digit, and it had done a pretty good job. Then this script is for EDA graph, and these are the EDA distribution for the classes. As you can see, there are some of the classes has so much data set and some has very few data set. In the end, this script is used for integrating both LLM and CNN model. And in the end, this script for the UI UX of the model. So finally, after the tech stack, we used for deep learning used PyTorch and Torch Vision, and for CNN model ResNet 50. So for LLM engine, we used Google Gemini 3.6 Flash, and front-end application Streamlit with custom CSS. So future enhancement, future ideas for this model are tried. So creating a vector embeddings of the dataset. Imagine the user uploaded the images, and the model can still give more similar pictures in the bottom. Then we have a museum audio guide. So this is text-to-speech API where the description that the model has given. So it could be listened in the professional audio tone. Then we have clickable canvas exploration. Suppose you upload any images, you can have a particular object to be clicked and more detail about the object. So then cloud database user galleries. So this is a login system where you can save all the upload images in the model. Then in the last, we can implement heat map visualization, where it shows the thermal heat map overlay, which gives us the idea about the brush strokes and color palettes. In the last, this is about model-based installation. You can have go through this and you can install it in your system. Thank you.